All right, so section 5.5 is going to be moderately friendly. There isn't anything that's specifically new in section 5.5, and I could have made section 5.4 and 5.5 into one long section, but I knew I couldn't do the material in a day. So every problem in section 5.5 has the same feel as section 4.4, in that I'm given a fraction, and I'm asked to find the same features of the graph of the fraction that I was asked to find in section 5.4. But in this section, we have the additional and graph. So I'm going to find, for problem 2, all the parts A through E. Then I'm going to sketch a graph. I'm going to put all these features, the ones B, C, D, and E that I find by hand, I'm going to show those by hand on my graph that I draw. And then I'm going to use my calculator to get the specifics of the graph shown, and I have to play with the window. There's a certain art to getting a window that's going to show all the features the best as possible for your graph. So for the domain and the vertical asymptote, I take the denominator, set it equal to 0. Because there's not a square, I'm going to solve this by getting the x's on one side, the numbers on the other. So I get 2x minus 2x plus 2 equal to 0, setting the denominator equal to 0. Subtract 2 from both sides, I get 2x equal to negative 2, and then divide by 2, and I get x equal to negative 1. That will be the equation of the vertical asymptote, but not the answer for the domain. I'll go, the domain is all real numbers, and then accept the negative 1. If you just wrote x equal negative 1, you're not excluding the negative 1. You're saying the domain is only negative 1, which is exactly opposite because it's everything but negative 1. The vertical asymptote is just that algebra, the result of the algebra from the domain, unless the original problem could factor and cancel the x out of the denominator that caused the solution to part A, but that won't occur in any of our problems, so it's not an issue to worry about. For the horizontal asymptote, I write y equals. I divide the highest x power terms in the numerator and the denominator. In this case, I'm going to divide y equal to 4x divided by 2x. The x's are going to cancel, and 4 divided by 2 is 2. The answer to the horizontal asymptote, it's going to have an equation of y equal to 2. For the x-intercepts, I set the numerator equal to 0. So I'm going to go x minus 12 equal to 0, 4x minus 12 equal to 0. No square, so I don't need to factor. I add 4x to both sides and get 4x, I add 12 to both sides and get 4x equal to 12. I divide both sides by 4 and I get x equal to 3. The x-intercept is going to be at the point 3, 0. For the y-intercepts, I plug 0 in for x. I go f of 0 equals 4 times 0 minus 12 over 2 times 0 plus 2. That's going to give me negative 12 over 2, and negative 12 over 2 is negative 6. The y-intercept is going to be the point 0, negative 6. So I'm going to show on my graph a vertical asymptote at x equal negative 1, a horizontal asymptote at y equal to 2, x-intercept at 3, 0, y-intercept at 0, negative 6. And then I'm going to borrow the rest of the graph from my calculator. And it may take some playing. The standard window might not be the best window to do this. So as I start to sketch my graph, make it something fairly big. First thing, I know there's a vertical asymptote at x equal to 1, negative 1. So I'm going to find negative 1 on my x-axis. And usually what we do is we draw a dashed vertical line as opposed to a solid line, so it doesn't look like the x-axis, or should I say like the y-axis. So that's the first feature of the graph I'm going to show. The graph won't cross that line nor touch that line. The next thing I'm going to do is a horizontal asymptote at 2. So I find 2 on the y-axis, and I do the same thing. I'll draw a line parallel to the x-axis. It's supposed to actually be perfectly horizontal, not have that little bump in it, but it does, so let me fix it. So just in case that's bugging you. It's not really bugging me, but I know I can do better than that. So I find -1 on the x-axis, 2 on the y-axis. From -1 on the x-axis, my line should actually go through the -1. 2 on the y-axis, my line should actually go through the 2. And then an x-intercept of 3, y-intercept of -6. So 3 is going to be 1, 2, 3. The graph is going to cross the x-axis at that point, 3, 0. And then I really didn't leave myself room for -6. I'm just going to call this the point -6, 0. Best I can. Now I'm going to graph the function and make sure I see graph on either side of the vertical asymptote and make sure I see the effect of the horizontal asymptote. So I'm going to take the equation, 4x minus 12 over 2x plus 2, put that in my y equals. So I'm going to go parentheses 4x, x4, parentheses 4x minus 12 divided by parentheses 2x plus 2. If I just do a zoom standard, I'm not sure how much of the graph I'm going to see, but it looks like this actually might be okay. Let me draw in now the asymptotes. First I'm going to draw x equal -1. Can't draw that real well. To do the x equal -1, I'm going to go 1,000. Actually on a y2, I'm going to go 1,000 times x plus 1 to get that feature drawn. That will draw a line that looks like the vertical line, x equal -1. And I'm going to draw y equal to 2. It's just y3 equal to 2. And now when I hit enter, my graph's going to throw in the asymptotes for me. Something that looks like the vertical asymptote there, something that is the horizontal asymptote there. I like that picture quite a bit. So I'm just going to copy that picture into my graph. So I'm going to have a segment in the upper left and a segment in the bottom right. The segment in the bottom right has to go through both the x and the y intercepts. And so this segment in the upper right looks something like that. The segment in the lower left, I don't like this window so much that I picked. It goes up like that. I could still do better. I'm really having a slow start. But that would be adequate for my purposes, for testing purposes. But come on, I can do better than that, I suppose. So in terms of a graph, that last thing that I had is adequate. This thing will be better, neither of which will be great. So I'm going to call this the point 30. This is the point -60 or 0, -6. And now draw my graph. This region up here look like that. This region over here looks something like that. Just so I can kind of see how the graph is getting close to the asymptotes. And that's all the accuracy that I need. I don't need, you don't need to plot extra points. When you get into calculus, you'll be able to do these graphs without your calculator and make a pretty accurate graph. And for our purposes, I just want you to just get used to what the graphs of fractions look like and identifying or drawing in the important features to the graph. So this is a reasonable picture. Certainly not an awesome picture. You can probably do better than I do, but this is more than good enough for the graph for problem 2. Shows all the features because it shows the x equal -1 vertical asymptote, the y equal 2 horizontal asymptote, the x-intercept and the y-intercept, and those are the features that I need to see. So there's 1, 2, 3, 4 things that I need to see on the graph, and I showed them all. So now we'll get to the problem 4. Do exactly the same thing. The algebra shouldn't mystify me to do these. The graph might be kind of cumbersome to get the window, but I should be able to get all the parts. For the domain, I take the denominator, 4x squared minus 1, set it equal to 0. There's a square I'm going to solve by factoring. That's a difference of squares. It factors into 2x plus 1 times 2x minus 1 equals to 0. I'm going to set both 2x plus 1 equal to 0 and 2x minus 1 equal to 0. When I set the 2x plus 1 equal to 0, I minus 1 from both sides and get 2x equal to negative 1. I divide by 2, and I get x equal to negative 1/2. That answer is going to be one of my vertical asymptotes. And for the other side, 2x minus 1, I add 1 to both sides and get 2x equal to 1. Divide by 2 and get x equal to 1/2. That's going to be an equation of a second vertical asymptote. And for the domain, I'm going to say the domain is all real numbers. I'm going to abbreviate numbers like that. And then I'm going to write the word except to exclude the negative 1/2 and 1/2. And I'm going to write plus or minus 1/2. And this would be an adequate answer for writing the domain in words. If you just wrote the vertical asymptotes, you'd be saying the only numbers I can plug in are negative 1/2 and 1/2. And that's wrong. Those are the only numbers you can't plug in. For the horizontal or vertical asymptote, or horizontal asymptote, I'm going to go y equals, take the highest power x term in the numerator, which is x squared. I'm going to emphasize there's really a 1x squared. In the denominator, the highest power term of x is 4x squared. The x squareds are going to cancel, and I'm going to get y equal to 1/4 as the equation of my horizontal asymptote. That's just going to be barely above the x-axis. For the x-intercepts, I take the x squared minus 4, which is the numerator, set it equal to 0. I can factor that into x plus 2 times x minus 2 equal to 0. Then I can set the x plus 2 equal to 0 and get x equal to negative 2. Set the x minus 2 equal to 0 and get x equal to 2. My x-intercepts are going to be the point negative 2, 0 and positive 2, 0. For the y-intercepts, I go f of 0 equals to 0 squared minus 4 over 4 times 0 squared times minus 1. The pieces with the zeros cancel out. I'm left with minus 4 over minus 1, which is positive 4. The y-intercept is going to be the point 0.04. So I'm going to try to draw all those features. I'm going to draw dashed vertical lines through positive and negative 1/2 at the x-axis. I'm going to draw a dashed horizontal line through 1/4 on the y-axis. I'm going to mark the points negative 2 and positive 2, 0 and 0.4. And then steal the rest of the graph from my calculator. So best I can do. And it doesn't have to be that horribly accurate, but just as long as it kind of gets the feel for the graph. So I need to have negative 1/2 and positive 1/2 vertical asymptotes drawn. So this right here is the vertical asymptote at x equal negative 1/2. This is going to be the vertical asymptote, best I can, going through 1/2 on the x-axis at x equal positive 1/2. And then if I find 1 on the y-axis, y equals 1/4 is barely above the x-axis. It's 1/4 of the way between 0 and 1. So here's the horizontal asymptote at y equal to 1/4. I'm afraid my calculator might make the asymptote look like it's the x-axis itself, but I'll deal with that in a minute. I get an x-intercept at 2 and negative 2, 0. I should label the points. So negative 2, 0 and 2, 0. And a y-intercept at 0.4. It's everything I need in terms of the features that need to be shown on the graph that I can get by hand. Vertical asymptotes, 2 of them, the horizontal asymptotes, and the 2 x-intercepts and the 1 y-intercept. Now I'm going to graph this and hopefully find a window that shows everything that I need to see. So I'm going to go y equals, I'm going to clear out the junk that's in there, and I'm graph the function, parentheses, x squared minus 4 divided by parentheses, 4x squared minus 1. Just do a zoom standard to start and see how much of the graph I can see. I think I'm going to have to zoom in on the y's. I think that the y's, being as high as they are, aren't helping me. I need my y's to crunch down a little bit, and it looks to me, I think if I can make the bottom y kind of maybe there like -5, and maybe the top y up here maybe like 7 or 8, and crunch the x's down a little bit, maybe to the 4s, I might do well. So let me maybe try the y's at -7 to 7, the x's at -3 to 3, because from this I don't see much. I need to zoom in on this a little bit. So I'm going to go x's negative, I said 3 to 3, I'm going to go -4 to 4. There isn't a right and a wrong window, but you want to be able to see all the features that I'm going to ask to graph. And now at this window, better things are happening. Like I said, I suspected the graph was going to make it look like the x-axis was the horizontal asymptote when it's not, but I can maybe do a little bit better by crunching the window a little bit more. But as I crunch the y's in and make it narrower, I lose this region. But let me just make it a little bit narrower. I'm going to change the y min to -5, the y max to 6, and see if I start to see better things. And I kind of don't see, it's not noticeably better. So I'm going to copy this graph. I'm going to get this little kind of parabola in the middle and these little, I don't know what you call them, on the sides. I'm going to make sure my graph goes through the y-intercept and both the x-intercepts and gets attached to the asymptotes. So let me draw the asymptotes in. The y-asymptote was at 1/4, so I'll just go 1/4 for it. The x-asymptotes, I'm going to go 1,000 times x minus 1/2 for the positive 1/2 one, and then 1,000 times x minus a negative 1/2, which is plus 1/2 for the other one. So now when I draw this, there's the horizontal asymptote that it's getting close to. Those are the vertical asymptotes. And now I can see everything. I'm just going to copy the rest of the graph into my graph. So this region kind of looks like it's doing something like this. It goes through the y-intercept, gets drawn to those vertical asymptotes, and then it crosses the horizontal, it doesn't cross the horizontal asymptote, it crosses the x-axis, and looks like that in that region, and in this region, it looks something like that. I would guess that when I give you a graph to do on the test, that I'll give you a blank graph that has a window set so that you'll not have to play on the test to figure out a window. And as you're doing the homework problems, I'm pretty sure if you look at my solutions manual, I tell you the window that I use. So if you're having a hard time figuring out which window is going to show you all the features, on the homework, you can look at the solutions manual. That should be given. And on the test, I think I'll give the window to you so you won't have to play so much. You can barely see 6. It says 4/3x. F of x equals 4/3x. For the domain, I set the denominator equal to 0. Set 3x equal to 0. I divide both sides by 3. I get a fraction with 0 in the numerator. So x equals 0 is the result of the algebra. That's going to be the equation of the vertical asymptote. And the domain, I'm going to write as all real numbers except 3. And I'm abbreviating all real numbers a little bit, except 0. Horizontal asymptote, there's only one piece in the numerator and one piece in the denominator. So that's the fraction I have to form. Doesn't reduce at all, and there's an x left in the denominator. When there's an x left in the denominator, the x-axis is the horizontal asymptote. The equation of the x-axis is y equal to 0. So there's no canceling that can be done. There's no fractions that you can't take. There's only one piece in the numerator, one piece in the denominator. So that's the fraction I have to live with to find the horizontal asymptote. It doesn't reduce, and there's an x in the denominator, so it's y equal to 0. For the x-intercepts, I take the numerator and set it equal to 0. The numerator doesn't have an x, so there's no solution to that. This graph is never going to cross the x-axis. There's not going to be any x-intercepts. Similarly, when I plug 0 in for x to get the y-intercept, I go 4/3 times 0. I get 4/0, which is undefined. If you get undefined when you're trying to find an intercept, you're not going to have that kind of intercept either. So the only things I have to really show are the asymptotes. The x equals 0 is the y-axis, y equals 0 is the x-axis. There's no intercepts to show, so as I go into graphing mode and I start to do my graph, the only features I can show are the equation x equals 0 and y equals 0. The x equals 0 is the equation of the y-axis. Y equals 0 is the equation of the x-axis. The graph doesn't have any x or y intercepts, so I'm not going to plot those. I'm going to hit my y equals button, clear out everything that's in there, type 4 over 3x. Put 3x in a parentheses to be safe. I think a standard window will work. I'm going to go zoom standard and see what happens. And that's probably reasonable. Maybe if I crunch the window down to the 5s a little bit, I'll see a better picture. Let me just go -5 to 5 on the x's. Although that picture wasn't bad, I think this window might show a little bit better the graph and the impact of the asymptotes. So I'm going to draw something like that. That's not noticeably different than what I did at the 10s. So you can see there's a bottom left and a top right half, and how the graph gets drawn to the asymptotes. I'm just going to copy that in, not sketching any points, just doing something like that for one half and this for another half. That's more than accurate enough. If you want it to be nice, and put arrows at the end of each of the regions, because the graph doesn't stop, it goes on forever. This graph never crosses the x-axis nor the y-axis, so it doesn't have any x or y intercepts, because you only get x and y intercepts where a graph crosses the x-axis. So this was 6, for what that's worth. I should probably be writing that down. 8, another fraction. For the domain, I take the denominator, x squared plus 4x minus 12, set it equal to 0. Square, so I solve by factoring. That factors into x plus 6 times x minus 2. I set the x plus 6 equal to 0, the x minus 2 equal to 0. When I set the x plus 6 equal to 0, I solve that. That gives me the vertical asymptote of x equal -6. Solving the x minus 2 equal to 0, you get the vertical asymptote at x equal to 2. For the domain is going to be all real numbers except -6 and 2. For the horizontal asymptote, I take the highest power term, x power term in the numerator, which is the x, and that in the denominator, which is the x squared. I go x over x squared, which is really x over 2 x's. 1x from the numerator cancels, but not both x's from the denominator. This reduces to a fraction that has an x in the denominator. So the horizontal asymptote is the x-axis, which has the equation y equal to 0. For the x-intercept, I set the numerator x minus 1 equal to 0, and I get x equal to 1. The y-intercept is kind of not a good one. It's a fraction that's going to be not that easy to see. So I'm going to go 0 minus 1 over 0 squared plus 4 times 0 minus 12. That's going to be minus 1 over minus 12, which is positive 1/12. That's going to be the point 0, positive 1/12. That's going to be so close to the origin that it's going to look like the graph is going through the origin. So I'm going to plot these, the two vertical asymptotes, the horizontal asymptote, and my x and my y intercepts on a graph to get started. So I need a 2, 3, 4, 5, 6, a vertical asymptote at -6, a vertical asymptote at +2. So I find -6 on the x-axis, draw a vertical line, more or less vertical, I guess. Find 2 on the x-axis, draw a vertical line through it. Probably be nice if I actually wrote the equations above this thing. This is the x equal to -6. This is x equal to 2. I can tell what the equation is, but it would be nice, if you threw that in there. And then the y equal to 0, that is the equation of the x-axis. And then lastly, the x-intercept at 1, there's the point 1, 0. And then 0, 1/12 is going to be so close to the origin that you won't be able to really distinguish it from the origin. But that's the point 0, 1/12. Those are all the features that I need to mark on my graph. I'm pretty sure I know what this graph looks like, but I teach the class and I've graphed a lot of fractions, and I probably can guess pretty nicely at a window, but I will just start with a standard window and then refine. So I'm graphing x minus 1 divided by x squared plus 4x minus 12. Zoom standard just to get the standard window going. And I don't think that's going to be good. I think I'm going to have to crunch it a little bit. And I think if I crunch the y's down considerably, I'll see a better graph than that. Although that's not a bad graph. It's not perfect. Let me crunch the y's down to the 3's. I'm going to go -3 to 3 on the y's. And when I do that, I think I'll see a better looking graph. You'll see better the effects of all the intercepts. Now I'm going to draw the y. I don't need to draw the horizontal asymptote because the axis is already drawn. But I'm going to draw the -6 and +2. To do the -6, I'm going to go 1,000, or if I could actually put it in the right spot, go 1,000 times x plus 6 to get the vertical, something that looks like a vertical line at -6, and then do 1,000 times x minus 2 to get something that looks like the vertical asymptote at 2, and then it draws, when I hit graph, it will draw the vertical asymptotes for me as well. And I'm going to copy that graph onto my paper, making sure to go through both the x and the y-intercept because those are important features. So there's 3 parts. There's this left region that looks something like that. The middle region that looks something like this goes through both the y-intercept and the x-intercept, and then the upper right region that looks something like that. So that's reasonable. Maybe throwing arrows at the end of these would be nice, but again, if you forget the arrows, it's hardly that big of a deal. And this is not an ultimate perfect graph. When I wrote my keys, I just stole graphs from my computer program and put those on there so they look so much nicer than this. Okay, but that's good enough. It does everything it needs. It shows the 2 vertical asymptotes, it shows the horizontal asymptote, shows the x and the y-intercepts, and it is a reasonable copy of the picture from my calculator. First, slant asymptote. The windows are way harder on slant asymptotes. You need to usually blow them way out. For the domain, I take the denominator x minus 3, set it equal to 0. That says x minus 3 equal to 0. You get x equal to 3, which is going to be the equation of the vertical asymptote. And the domain is going to be all real numbers except 3. This is going to be a slant asymptote. I'm going to take the highest powered term of x in the numerator, which is the 2x squared, divided by the highest powered x term in the denominator, which is the x. This is going to be 2xx over x. I'm going to get y equal 2x, and this is going to be a slant as opposed to a horizontal asymptote. The x that doesn't cancel is left in the numerator, and you get a line, a slanted line as opposed to a horizontal line. Bad x-intercepts. For the x-intercepts, I have to solve 2x squared plus 5x plus 3 equal to 0. I'm going to pull out another sheet of paper just to do that so you can see the factoring just in case factoring's not your friend. This needs to be solved by factoring. I'm going to bottoms up it. I'm going to make this x squared plus 5x plus 6 by multiplying the 2 and the 3. I'll factor this into x plus 2 times x plus 3 because I have to multiply to 6 and add to 5. I started off multiplying by 2. I'm going to divide by 2. I'm going to get an x plus 1 and a 2x plus 3 for the factoring of 2x squared plus 5x plus 3. So this factors into x plus 1 times 2x plus 3 equal to 0. I'll set the x plus 1 equal to 0 and get an x-intercept at -1. the 2x plus 3 equal to 0. Subtract 3 from both sides and get 2x equal to negative 3. Divide by 2, get x equal to negative 3/2, which is negative 1.5. My x-intercepts are going to be the point negative 1, 0 and negative 3/2, 0. They're going to be really close to each other. It's going to make a funky graph. It's going to make it hard for me to see everything I need to see. The fact that the x-intercepts are so close to each other, that usually causes me to have the y's really close to the x-axis, like a y-min and a y-max at negative 2 to 2. Having a slant asymptote usually wants me to have y's like negative 50 and positive 50. To get two of those working together is going to be next to impossible. So as I draw the graph, I'm probably going to have to draw it in segments. The first segment, I'll focus on what's happening around these two x-intercepts, and then I'll show the slant asymptote feature, but I'll take my time to get there. For the y-intercepts, I go f of 0 equals 2 times 0 squared plus 5 times 0 plus 3 over 0 minus 3. That's going to give me 3 over negative 3, which is negative 1. So the y-intercept is the point 0, negative 1. I'm going to put those three features in there and the vertical asymptote. I'm going to hold off on the slant asymptote until I get my calculator graph, because it's going to be, to get the angle right based on the window that I'm showing would be kind of tricky, because slant asymptotes, they really get impacted by the viewing window dramatically. I'm going to hold off on putting it in to the very end. But I can certainly draw my vertical asymptote at 3. So this is the x equal to 3, which I'm going to type 1,000 times x minus 3 to get that kind of displayed. And I have a y-intercept at 0, negative 1, an x-intercept at negative 1, 0, and an x-intercept at negative 3/2, 0. This is the bad part. Doing that was bad planning on my part. So what I'm going to do very first is try to just focus on this little region of the graph to see what it looks like, and then I'm going to blow out my y's real big to see the impact of the slant asymptote. So I'm going to graph this function with a really narrow window to start. So I'm going to clear out all these things and go, you can see that, yes, 2x squared plus 5x plus 3 divided by x minus 3, enter, hit my window, and negative 10 to 10 on the x's might not even be okay. I'm going to really focus on this region. So I'm going to go like from maybe like negative 3 to 5 on the x's so I can see the vertical asymptote and be just around the x-intercepts. I'm going to really crunch in on the y's. I'm going to make my y's do down to the 1s. I think that's going to really show me well what's happening around the x-intercept, but I may be wrong. But I didn't. Even at that window, it wasn't that good. What's happening at the x-intercept is the graph is barely going. Let me just change my y's to be really something really extreme, like negative 0.1 to positive 0.1, and just really focus on that region. So that's what's happening between the x-intercepts. The graph is just barely going above the x-axis. Because when you go to like a standard window, go to zoom standard, you won't be able to see that at all. You can't tell at all what's happening. But what really is happening is the graph is going just barely above the x-axis, doing something like that. So that's kind of what's happening in the region around the x-axis. And let me draw that vertical asymptote in by going y equals 1,000 times x minus 3. Again, that's not exactly the equation of that line at all, but it mimics the vertical asymptote. So I have a picture. I have a left half but not a right half. This is because when you have slant asymptotes, you usually have to blow the y-mins and y-maxes way out to see a good picture. Let me blow the y-min and y-max way out. Leaving the x's at the 10 may be okay. Let me extremely throw the y's out to the hundreds, and see if that gives me the two pieces to the graph. I really lose perspective of what's happening around the intercept, and my vertical line at that window starts to looking a little less than vertical, but it's okay. I'll live with that. I'm going to draw now the 2x and hit enter and graph that. Now you can see the effect of the 2x. Ultimately, if your window is square, meaning your x parameters and your y parameters are the same, you get a better perspective of the slant asymptote, but you start to really lose the impact of the intercepts and the other features. But if I change the x's also to the hundreds, then I'd get a picture that's probably fairly awesome, but a picture that it's not so good. But look at that, you can see how nicely the graph follows the line y equals 2x in a big square window. But for my purposes, this window, it shows the effect of the slant asymptote really well, doesn't show the effect of the vertical asymptote very well at all, doesn't show the intercepts very well at all. So although that's probably an optimal window for the slant asymptote, it's not so good for the others. So I'm going to draw that window at the 10s and copy this picture. And this is kind of, you know, maybe not the best of both worlds. It's actually rather horrible in terms of how that y equals 2x looks, but I'm living with it because I'm stuck with having to live with something. So I'm going to draw this line so that the top region looks something like this, and I probably in this window have to slant this out a little bit more so it looks more like that as opposed to that, and then just draw this best I can. Should go through the origin. So the graph actually might cross that line twice. And although this probably wouldn't win any awards, it's a reasonable picture without that part. That part's probably drawn a little too extreme. That should be more like that. So something that, copy that the best you can. Show the impact of the x-intercepts and y-intercepts, meaning right at the x-intercepts, the graph kind of bubbles up and goes just slightly above the intercepts, and then it works its way down like that. And that's certainly not an awesome picture. It's not even remotely good. But we're fighting a couple things here. The intercepts need kind of one window. The slant asymptotes need another window. It's hard to get a graph to show each of those features perfectly. So without that part, the graph looks, you know, like that on that window, and that window is at -10 to 10, -100 to 100, -100 to 100. That's a reasonable picture. It's definitely probably not something I'd like to show another math teacher because of, you know, the axes being so dissimilar. The x and the y axes being, you know, one at the 10s, the other at the 100s. That really kind of does bad things to the slant asymptote, but I'm living with it, and so that's good enough. We're not looking for perfection here. It's just something that reasonably models the graph, shows the features. I'm content with that. This is another slant asymptote problem, but it's not as bad because it's a fraction slant asymptote, and those seem to fit better. So for the domain, it's going to be bad. Take the denominator, 12x minus 5, set it equal to 0. Add 5 to both sides, get 12x equal to 5. Divide by 12, I get x equal to 5/12. The domain is going to be all real numbers, except 5/12. If you write x equals 5/12 for the domain, I won't even give you partial credit. That's just completely wrong. It's the right number, but it's just wrong. So if you did the vertical asymptote answer in your domain, bad things will happen in terms of partial credit because it's not right. That's not excluding. You need some words or symbols or something to exclude 5/12, and just saying x equals 5/12, although it's an important number, it's not the answer for the domain. 5/12 is just a little bit less than 1/2. So when I draw that, I'm going to draw a vertical line just slightly to the left of 1/2. This is going to be another slant asymptote. I'm going to go y equals to 3x squared over 12x. This is going to be 3xx over 12x. The 1x cancels. 3 over 12 reduces to 1/4. And probably writing 1/4 x is probably the nicest way to write the equation of this slant asymptote. For the x-intercepts, I set 3x squared equal to 0. Divide both sides by 3, probably would be nice. This would give me x squared equal to 0. And I can do square root plus or minus square root if I want. This would give me x equals plus or minus 0. Plus 0 is 1 times 0, it's 0. Minus 0 is minus 1 times 0, it's just 0. There is no plus or minus 0. Plus and minus 0, they're both just 0. Plus and minus 1 are distinct numbers on either side. You know, one to the positive, one's negative. But plus or minus 0 is just the number 0. So the x-intercept is going to be at 0, 0. For the y-intercept, I'm going to go 3 times 0 squared over 12 times 0 minus 5. The pieces with 0 turn into 0. I get 0 over minus 5, and that's equal to 0. So the y-intercept is also going to be 0, 0. This I might be able to get by on a standard window. So when I go to graph this, I'm going to show the features that I need to show. The 0, 0 x and y-intercept, the 5/12 vertical asymptote. I'm going to hold off on drawing the 1/4 x for a minute here. So the x equal to 5/12. 5/12 is just less than 6/12, which is just less than 1/2. So my vertical asymptote goes just in between just close to 1/2. And then 0, 0 is both the x and the y-intercept because 0, 0 is both on the x and the y-axis. Eventually I'm going to draw the 1/4 x, but I'm going to hold off on it before I'm going to steal a picture from my calculator first. So I'm going to go y equals 3x squared divided by parentheses 12x minus 5. Zoom standard to start. And I think I'm going to have to crunch the window. So the 1/4 was nice. I can't really tell at all what's going on here by the x-intercept, nor probably can I see the vertical asymptote real well that I haven't even drawn in yet. I'm going to make my windows go down to the 3s. I'm going to go x min -3, x max 3, y min -3, y max 3. See if I can see better what's happening around the origin. I think I can. See if I could see better probably the asymptote. I think this window is going to be perfect. Let me draw in 1,000 times x minus 5/12 for something that simulates the vertical asymptote. So this is now going to draw in the vertical asymptote. And the graph gets really close to it. Probably crunching my window down even more would be better. But the graph is going to be just on either side of that vertical line. And then we draw the 1/4 x in also. So parentheses 1 divided by 4x graph. And, oh, that's actually nice. So this is a nice window. The window at the 3s is really nice where I can kind of see everything. I'm going to draw this line, just kind of mimic it a little bit. So it looks something like, has a slope of 1/4 for what that's worth. And in a square window, it looks okay. So this is the y equals 1/4 x. And then I'm drawing this part that I think does this, and this part that I think does this. I think this is a reasonable copy of my calculator's graph. If I wanted to, if I made the window even tighter, like maybe go to the 1s on my x's and my y's, I might see even a picture that I'm happier with. Maybe I won't, it's hard to say. I don't know that that's noticeably better, maybe it is. But now you can see the graph actually crosses that slant asymptote and then gets drawn to it, and then up here it just kind of stays away from it. So again, there isn't a perfect window, especially with with our graphing calculators. Using a computer program, you just get better pictures, and for whatever reason, it is what it is, but it's good enough. This graph would be completely adequate for any test question on number 12, because it certainly shows the slant asymptote, the vertical asymptote, the x-intercept, the y-intercept, which is the same point, and the features of the rest of the graph, that looks reasonable. 16, to find the domain, I take the denominator, set it equal to 0. I go x minus 5 equal to 0. No factoring to do. I just add 5 and get x equal to 5. For the vertical asymptote, the domain is going to be all real numbers except 5. Again, if you just wrote x equal 5 for the domain, I'd take points off. For the horizontal asymptote, I like y equals. The only thing in the numerator is 3, so that has to be my numerator. The x term in the denominator is just that x. This doesn't reduce. There's an x left in the denominator, so you get a horizontal asymptote and not a slant asymptote. It's going to be the x-axis, or y equal to 0. For the x-intercepts, I take the numerator and set it equal to 0. There's no x, so there's no solution to that. This graph's not going to cross the x-axis. For the y-intercepts, I go 3 over 0 minus 5, which is 3 over negative 5, which is negative 3/5. The y-intercept is going to be 0, negative 3/5. It's everything that I need to show. So I need a vertical line going through 5. I need the x-axis and a y-intercept really close to the origin. So as I go to graph this, I like having the multicolors. You don't have to use multicolors, but it seems to make it easier to show the features. So x equal 5 is my vertical asymptote. So I find 5 on the x-axis, draw a dotted vertical line just so it doesn't look like it's another y-axis. That's the x equal to 5. The horizontal asymptote at y equals 0 is actually the x-axis. And then the y-intercept at negative 3/5. Negative 3/5 is more than half the way between 0 and negative 1. That looks like maybe there is the point 0, negative 3/5. Now I'm going to copy a graph from my calculator. I'm going to start with a standard window. I'm not sure how well the standard window is going to work. It might not show this part real well. I think I'm going to have to go wider on the x's, but the y standard might be okay. So y equals, clear this junk out of here. Put in 3 divided by x minus 5. Go back to a zoom standard. See if I can see the impact of the asymptotes. Maybe I can. Maybe that's good enough. Draw in the vertical asymptote going 1,000 times x minus 5, again to mimic the vertical asymptote. I don't need to draw the y equal to 0, but I could. It's just going to be the x-axis, and I won't see it anyways. I think that's reasonable. I'm going to copy that picture, get 2 parts. The left part goes through the y-intercept. They both kind of get drawn to the vertical and horizontal asymptote. So I'm going to take this region, draw that, this region, make sure it goes through the y-intercept because that's an important point on the graph. And I should really put arrows. I know I don't often put arrows, but just to signify that the graph doesn't end and it keeps going in the direction that it's going. So a nice basic standard window function was really enjoyable. Only a few more of these left. Another slant asymptote. For the domain for problem 16, I take the denominator x minus 3, set it equal to 0. When you set it equal to 0, there's no factoring to do. You add 3 to both sides. The solution for that is the vertical asymptote of x equal to 3. The domain is all real numbers except 3. This is going to be a slant asymptote. I'm going to go y equals x squared over x. That's 2x's over 1x. I'm left with y equal to x, and this is going to be a slant asymptote because the x wasn't left in the denominator. If the x was in the denominator, it would be the x-axis. For the x-intercepts, you set x squared equal to 0. You go square root, plus or minus square root. You get x equals plus or minus 0. That's only one number. That's just 0. The x-intercept is 0, 0. For the y-intercept, I go 0 squared over 0 minus 3, which is going to be 0 over minus 3, which is also going to be 0. So the y-intercept is also going to be 0, 0. So I'm going to draw my vertical line through 3. I'm going to make my 0, 0 point. I'm going to hold off on drawing that y equal to x. I'm not sure what kind of window I need, but I think it's still going to need a reasonably big window to show that. And again, I might have to play to get both the impact of the intercept and the slant asymptote at the same time. So that's the beginnings of a graph. Now I'm going to do x squared divided by x minus 3. So y equals, clear this out, clear that out, x squared divided by parentheses x minus 3, zoom standard, and hopefully that gives me something that looks reasonable. I see a left half. I see how it's impacted. I can kind of see what's happening at the origin here. Let me zoom in on this so you can see what's happening at the origin. Also draw the vertical asymptote in temporarily. So y equals, I'm going to draw the vertical asymptote by going 1,000 times x minus 3. Change my window, just so you can see, change my window to go real tight on the y's so you can see better what's happening around the origin. And the graph at the origin is not actually crossing the origin, it's just touching it and going away. So when I go to draw my graph, the graph's at the origin is not going to go above it. Okay, now I don't see a lot here. I'm going to zoom way out on my y's to the 50s to see the impact maybe of the slant asymptote. So there's one half, there's the other half. That's reasonable. There's the vertical asymptote. Now I'm going to draw y equal to x for the horizontal asymptote. You'll see the graph get drawn to it. Might be nice if my window was square, the x's and the y's being the same. That shows the graph the best, I think. So I'm changing my x's to the 50s as well. And this would be a fairly good picture in that you can see the impact. You can still see the vertical asymptote a bit. You can see the horizontal, the slant asymptote. I don't know if that's the best window. Maybe go down to the 30s and see if that still gives me a reasonable picture and doesn't muddle some of the graph so much. There isn't a right and a wrong window. That's probably a really nice window. So x min, x max at negative to positive 30, y min, y max at negative to positive 30. That's a really nice graph. So the graph crosses the slant asymptote and then gets drawn to it in this bottom region. So in this, when I draw the graph, the slant asymptote, y equals x, is a line that goes to the origin at a 45-degree angle if the x min and x max and the y min and the y max are the same. Meaning you have a square window. I have this top region that looks something like this, and this bottom region that gets it goes above and then down like that. It doesn't actually cross the axis there. It just touches the axis and bounces off. So it looks something like that. That's got to be a good enough picture for number 16. And these aren't works of arts that anybody would, care to write, but this is good enough. It's not like if you did this on a test, it's all you need to do. I'm not going to get any pickier than that. I think 18 is the last problem. Has two vertical asymptotes. For the domain, I take the denominator and set it equal to 0. Go x squared minus 25 equal to 0. Easy enough to factor that. I'm going to go x plus 5 times x minus 5 equal to 0. When I go x plus 5 equal to 0, I get x equal to negative 5. When I set the x minus 5 equal to 0, I get x equal to 5. Those are the equations of the vertical asymptotes. The domain is going to be all real numbers except negative 5 and 5. For the horizontal asymptote, I'm going to go y equals 3x over x squared. That's 3x over a couple of x's. I'm left with an x in the denominator, so the x-axis, which is y equals 0, is the horizontal asymptote. Easier to graph those. For the x-intercept, I take the numerator and set it equal to 0. When I take 3x, set it equal to 0, I divide both sides by 3. You get x is 0 over 3, which is 0, so the x-intercept is 0, 0. For the y-intercept, I go 3 times 0 over 0 squared minus 25, which is 0 over minus 25. Any fraction with 0 in the numerator is equal to 0. So I'm going to draw -5 and +5 vertical asymptotes. The x-axis is going to be the horizontal asymptote. I'm not going to need to draw that. It's already drawn for me. And 0, 0 is the extra point that I'm going to need. So as I go to sketch a graph of this function, I don't know if a standard window is going to work. I might have to crunch the y's on my standard window. So I need to find -5 and +5 and make vertical lines. Let's call those my vertical asymptotes. So one at x equal -5, another one at x equal to 5. I get the x and y intercept at 0, 0, and the horizontal asymptote at y equals 0. Those are all the features that I need to have. Now I need to get a window to show the impact of everything. Turn my y equals on, clear, 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 do 3x divided by x squared minus 25. Notice every time I put my denominator in a parentheses and my numerator in a parentheses, and then 1,000 times x plus 5 will give me something that looks like the x equals -5. 1,000 times x minus 5 will give me something that looks like x equal to 5. Let me zoom standard and see what happens. Zoom standard. I think I'm going to have to make the y smaller. Yeah, it's not so bad, really. Actually, I'm semi-content with that as it sits. If I make the y's any smaller, I'm not sure it's going to be much better. If I make the y's go like from -6 to 6, I don't know if that's going to make it noticeably better. And maybe it makes it slightly better. But that -10 to 10 picture seemed fine. So I'm just going to copy this, make sure my graph goes through the intercepts and gets dragged to the vertical and horizontal asymptotes. There's a top left, a middle, and a top right, a middle, and a bottom left region. The bottom left region I'm going to draw like that. The top right region I'm going to draw like that. And then the middle region I'm going to draw something like that. And take my arrows. Since that more or less looks like the calculator drawing again. I'm not looking for perfection. So if this was a test question and this is the graph that you produced for number 18, or a test question that had number 18 as its question, that would be completely adequate. Again, I should give you the window that you need when I make up the test, so you won't have to play around with the window. When you're doing the homework and the review, if you just can't get a window to show the features, then you can look at my solutions manual. I believe I have the windows shown there so that you can figure those out, but you won't have to figure the windows out for a test. So just one more section of new material in Chapter 5. It's not supposed to be too bad of a section. Then we'll do the review, then we'll have the test. And then I would kind of consider the class half over, even though we do 7 chapters and we're done with 4, which is slightly more than 7. Chapter 6 is a long chapter. It's almost like 2 chapters in length. So there's more sections in Chapter 6 than there is in any other chapter. So we're kind of halfway done with the material, maybe slightly more than halfway done.